Our final presenter will be Keegan, who is the operations engineer for Washington DOT and the new AASHTO TSP2 bridge preservation engineer. He's going to present on what they're doing in Washington with regards to sealer.
Thank you very much, Tom. Quite impressed by everyone was in here before me. State of Washington is really starting kind of late into this process. This is about deck seals in Washington. We've been really at it for about 4 years now. Deck seals during the early years we first tried them back in mid 80s. We built Interstate 82. We had some progressive engineers who thought it'd be a good idea to seal the decks. Interstate 82 is over on the east side of the state. It's lots of snow, lots of frost, lots of icing. So it'd be a good idea to seal those decks. And so they came up with a contract, developed specifications, everything else went out. East side in the summer, temperatures are usually in the 90 to over 100 degrees. And it was a disaster because neither the state nor our contractors were very familiar with deck seals and the use of epoxies. And the epoxy set up before the aggregate could be set. And we ended up with slick decks or the epoxy peeled off. So we ended up grinding off the epoxy. And for the next 35 years or so, we did no deck seals. We have long memories within the department. In the last 10 years, the DOT moved to a ultra high performance concrete for new decks. And we specified what the mix was going to be. Unfortunately, the decks cracked like crazy, even though the contractor did everything according to specifications. So in the last 5 or 6 years, we changed the performance specification to a performance specification, the amount of cracking, and included as a cure that the contractor would seal the deck if there was excessive cracking. Since then, there's only been one bridge deck of new bridges that exceeded the crack limit, and that was on 167 over 32 East, or the Puyallup River. On this one, I think what caused the excessive cracking was the existing steel truss that was alongside the new bridge was lifted up and placed on the deck of the new bridge about a month after the bridge was built and rolled off the bridge. We think this might have been what caused the excessive cracking. Here's a picture of it. This is the deck as it is now. On the right, you'll see some of the deck, but you can't see where the cracking is. So I tried to zoom in on this one to show the cracks. And what the contractor did, they used the high molecular weight methacrylate sealer on the deck. And it seems to be working very well. This was about 4 years ago. Now for our maintenance crews, it's been kind of a trial period for us. Started off with experimentation, kind of a realization. One of the problems is we didn't really have funding. For a long time, the state maintenance crews have been totally reactive, running out, fixing potholes, running out when bridges get hit, doing repairs, and not really have a very good preservation program. And the big problem has just been funding. And they really lack direction. So moving forward from there, as far as experimentation goes, the bridge crews would select which bridges they wanted to treat, what materials they use, how they prepared it, how it was installed. And of course, what the crews selected for the bridges are those with greatest number of problems, the worst first. Depending upon which vendor was around and who they worked with, they decided on the materials. And for the most part, crews just swept the bridge off, blew off the cracks. If they were things like oil and tar, they would sandblast and then blow that off. Installation method was mainly with squeegees and brooms on the product. And the material was applied by hand using 5-gallon buckets and spreading it like that way. Fortunately, about 4 years ago, we received an additional $6 million per biennium, that's $3 million a year, for additional preservation work. Now the bridge office got involved and worked with the region bridge crews to select bridge projects. And the deck seals were to be done on bridges with good conditions. And right now we haven't really zeroed in on what materials we're going to use, what preparation methods and so on, but we're working on it. Before we were start off doing it wrong, we tried to use a deck sealer on a bad deck. It doesn't glue it back together. It continues to spall, and it was a waste of time and money. So I checked with what other states were doing and worked with the vendors. I've worked with Oregon, California, Minnesota, Michigan. Ohio has some good programs and so on, trying to determine the best way to do this. One of the bridges that had the ultra high performance concrete on it was Manette Bridge, was built about 5 years ago. 51,000 square feet of bridge deck. Decided to do similar to what other people do, about 50 square feet, both of an epoxy material and a high molecular weight methacrylate. This is a bridge over a waterway. So similar to what other people were doing, we didn't want it to material to leak through. So I talked to the vendors. They each had a slightly more highly viscous material, both in the high molecular weight methacrylate as well as epoxies. This bridge had fairly large cracks, similar to what was shown on the very first presentation. When it rained, it poured through the deck. And the last thing I wanted to do was get in trouble with our environmental group because we had epoxies or methacrylate into the waters of the state. Preparation, we like to chain drag the deck to see if there's any delaminations. On this one, of course, there was not. There were no delaminations. All the vendors recommended shot blasting. Working with our maintenance crews and the vendors as a second possibility, they recommend using a P-Etch deck cleaner. Does a good job of cleaning the deck. The one drawback is, again, you have to, like the pressure washing, you have to wait 24 hours, make sure the cracks are dry. Does a really good job of cleaning it up. You look at the deck the day after they use the P-Etch material, it looks brand new, bright white, very clean. It does a good job. One thing the maintenance people found out, it's not so good for your boots. It just eats away at the material, and we end up buying new boots for a number of people. The vendor for the P-Etch material says it is environmentally safe, but we do close off all the drains and make sure that any material stays on the surface or moves to the shoulder. We do use a sweeper on the deck to begin with. Then another method was to sweep the deck, sandblast select locations, blow off the deck, make sure the cracks are clean, and then apply a sealer. This can also be done with just one lane closure. And here's a picture of the P-Etch being used. Again, using brooms, the water, and the P-Etch material mixed in with the water to clean the deck. Tired of using 5-gallon buckets to apply the material. So our smart maintenance people came up with a sand spreader on the back of a small pickup. And that did a very good job of broadcasting the sand over the material that we use. And it sped up the job quite a bit. So far to date, over the last 3 years, when we've been doing the decks using the new funding, we've completed about 450,000 square feet of deck. The average cost has been around $2 a square foot. We set up purchase contracts for epoxy material, the MMA and the high molecular weight methacrylate, so bridge crews can purchase off of those. The bridge office selects which candidate bridges they can address. They do allow the crews to select the preparation method for the bridge, depending upon how clean it is. We have yet to complete a cycle of 5 to 7 years. And other than Manette, we have not checked on results. On that one, for the first, where we had the two 50 square foot patches, I had our materials lab go out and core those. And there was slight penetration of about 1/16 to 1/8 of an inch visible penetration. Did not go through, which was my concern. I think that the regular viscosity of the material that they recommended to begin with would have worked just fine, but I didn't want to take the chance.
Thanks, Chris. Great preservation. And by the way, as I mentioned earlier, Chris is the new AASHTO TSP2 bridge preservation engineer. As you can see, he brings a tremendous amount of experience to the organization. And on that note, too, those of you that are consultants and new to the bridge industry, please spend time on the TSP2 website, where it'll acquaint you with the 4 regional chapters around the country, the working groups, which you can become involved with. There's also monthly calls and whatnot, and we're always looking for volunteers. With that, I'll turn it back over to John.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.